Hello my dear students, welcome to my YouTube channel Shiva Academy of Mathematics. In today's video lecture I am going to discuss certain examples related to directional derivatives. In the previous video I have discussed about the directional derivative, that how we can find the directional derivative in the direction of a vector. So I have explained the formula in that video. So let us start some examples related to directional derivatives. So before starting those examples, here are certain results related to gradient of a scalar function. So first note is, you can see that del phi always gives the maximum rate of change of phi, and the magnitude of this maximum is mod of del phi. So remember that this gradient of phi gives the maximum rate of change of this scalar function phi, and if you have to find the maximum of this magnitude of this maximum, then it will be mod of del phi. And some other results, just like del of phi 1 plus phi 2, that will be del phi 1 plus del phi 2. Del of phi 1 phi 2 will be phi 1 del phi 2 plus phi 2 del phi 1, just like we apply the product rule in the derivatives. Third one is just we apply quotient rule for derivatives. It is del phi 1 upon phi 2, so it will be phi 2 del phi 1 minus phi 1 del phi 2 upon phi 2 square, but condition is that phi 2 must not be equal to 0. So these are some results which can be helpful in your exams to compute the maximum rate of change of phi or magnitude of the maximum. So come to next slide. Just I have discussed, I have taken some questions based on the directional derivatives. So first question is that find the directional derivative of the function. So here is the question number 1. Find the directional derivative of the function f equal to x square minus y square plus 2z square at the point p1 2 3, at the point p1 2 3 in the direction of the line pq. So the point P is already given 1 2 3, and the point Q is 5 0 4. Point Q is 5 0 4. So we have to find the directional derivative of this function f in the direction of this line PQ, where P is 1 2 3 and Q is 5 0 4. And just I discussed in the previous slide maximum of del phi. So two more questions are asked in the same problem. In what direction it will be maximum, and find also the magnitude of this maximum. So we will discuss all these one by one. In the solution, we start from this f is x square minus y square plus 2z square. F is x square minus y square plus 2z square. So first of all, we find the gradient of f. This del f is what? I cap curl f by curl x plus j cap curl f by curl y plus k cap curl f by curl z. So we put the value of f here, just like if you have to find curl f by curl x. So f is x square minus y square plus 2z square, so curl f by curl x is 2x, and curl f by curl y is minus 2y, curl f by curl z is 4z. So it is del f is 2xi cap minus 2yj cap plus 4z k cap. And because we have to find this directional derivative at the point p1, 2, 3, so what we do, we put this 1, 2, 3. At place of x we put 1, at place of y we put 2, and at place of z we put 3. So we are getting this del fs because it is 2xi cap, so we put x equal to 1, so it is 2i cap. Value of y is 2, so it is 4j cap. Value of z is 3, so it is 12k cap. So finally we get del f. So when we have to find the directional derivative, so first of all we have to compute the gradient of the function. Whatever the point is given, so we put the point values, then we get the gradient of it. And because we have to find this directional derivative in the direction of the line PQ, so we find the vector in the direction of this line PQ. So you know this formula that this A equal to PQ. So we compute OQ minus OP, and OQ is what? Because this Q is the point 504, so it is 5i cap plus 0j cap plus 4k cap, because y coordinate is 0. Minus OP is what? Because point P is 1, 2, 3, so it is I plus 2j plus 3k. So when we take the difference of these two vectors, so finally we are having 5i minus I cap, it is 4i cap. It is 0j cap, it is minus 2j cap, so it is minus what? Del f dot a cap. So we find this unit vector. So a is 4i minus 2j plus k, and magnitude of this a is 4 square of 4 is 16, then 4 plus 1 it is root 21. So this a cap is what? 1 upon root 21, 4i minus 2j plus k. So for the first part we take the dot product of del f with this unit vector a. So I have written here, as we know that the directional derivative of f in the direction of a is given by del f dot a cap. This a cap is 4i minus 2j plus k upon root 21. So we take the dot product, you can multiply and divide by root 21 to more simplify. So you can get this answer also, 4 by 3 root 21. Both answers will be correct, no doubt. You can keep the answer 28 by root 21 or 4 by 3 into root 21. So this is the way to find the directional derivative of a function f in the direction of a vector. So you have to compute gradient of that function and the unit vector for the given vector. The next problem was asked in this is that in what direction it will be maximum. So you know that directional derivative of f is maximum in the direction of del f because 2k. So this directional derivative is maximum in the direction of this vector. 2i minus 4 is 16 and 12 square is 144. So you can more simplify in square root. You know variables can be asked that you have to find the direction. It will questions I have taken in this video. So we have to find the directional derivative of phi equal to phi x square minus phi y square z plus phi by 2 z square x. Solution: phi is given phi x square y minus the gradient of this phi, so del plus k curl phi by curl. So derivative of phi x square y with respect to x is 10 xy, then phi by 2 z square x, it is phi by 2 z square. So first term is I cap 10 xy plus phi by 2 z square, then j cap curl phi by curl y. So derivative of this first term phi x square y with respect to y is phi x square, then minus phi y square z, here is also y, so it is minus 10 yz plus k cap. We have to find the derivative with respect to z, it is again partial derivative. So minus phi y square z to 1 z equal to 1, and this del phi. So after putting x y z equal to 1, so we get del phi equal to 25 by 2i minus 5j. The term with this k cap is 0, so we are having only I cap and j cap terms. Now, dear students, remember that when we have to find the direction of the line, so we take the direction cosines from here, 2, minus 2, 1, because it is an equation of line passing through 1, 3, 0, having direction cosine to 2i minus 2j plus k, 2i minus 2j plus k. So again we make the unit vector, a cap equal to vector a upon magnitude of a. So vector A is 2i minus 2j plus k, and magnitude is under root 4 plus 1, that is root 9, that is 3. So it is 2i minus 2j plus k upon 3. So the required directional derivative is what? It is del phi dot a cap. So we take the dot product of del phi with this a cap, and finally we get the answer 35 by 3. Because calculation is simple, you can do easily. The dot product, I dot I1, I dot j, I dot k 0. So its answer is 35 by 3. So I have given one question for your practice. In what direction from 3, 1, minus 2 is the directional derivative of phi equal to x square y square z for maximum, and what is its magnitude? So I am giving hint to you that you compute del phi at which point 3, 1, minus 2, and directional derivative will be maximum in this direction, del phi, and after that you will compute this magnitude of del phi. So you will get both the answers. Here point is given 3, 1, minus 2, so you can solve it easily. Let us come to problem number 3. Again, it is a little bit different from previous two problems. I have taken various types of problems which can be helpful for your exams. So we have to find the directional derivative of the function phi equal to y upon x square plus y square at the point 0, 1, making an angle 30 degree with the positive x-axis. So it is a two-dimensional case. Previous two questions were the case of 3 dimension, so it is the case of 2 dimension. That's why we have given the point 0, 1. So because phi is y upon x square plus y square, so you compute again del phi. So it is I cap curl phi by curl x plus j cap curl phi by curl y. I have written value of phi here, it is y upon x square plus y square. So you have to compute del by del x and del by del y. So del by del x is computed directly because it is x square plus y square inverse. So when you compute, it is minus 2x. So y I have taken outside. So it is minus 2x upon x square plus y square whole square. But to compute this del upon del y, we apply the quotient rule, because in both numerator and denominator we are having y. So we keep x square plus y square as it is, derivative y is 1, minus y as it is, and derivative of x square plus y square is 2y with respect to y, x square plus y square whole square. So when we simplify, we get this value minus 2xy upon x square plus y square whole square I cap, plus it is x square plus y square minus 2y square, that is x square minus y square upon x square plus y square whole square j cap. So no need to do more calculations. So you just put the point this which have given 0, 1. So we put x equal to 0, y equal to 1. So first term is 0, so it is 0 I cap. And in the second term, when we put x equal to 0, y equal to 1, so it is 0 minus 1 upon 0 plus 1. So it is minus 1, so it is minus j cap. So del phi we get this as minus j cap. Now we have to find a vector. Because it is given that we have to find the directional derivative of this function phi in the direction of the vector making angle 30 degree with the positive x-axis. So the formula to get the vector A is what? It is cos 30 degree plus sin 30 degree j cap. because cosines will be cos 30 degree and cos 60 degree, but cos 60 degree is sin 30 degree. That's why I have written here sin 30 degree j cap. Because if you, it is the case that it is making angle 30 degree, so point P is there. So here x and y, so x is cos 30 degree, y is sin 30 degree. We keep the value of cos 30 degree, sin 30 degree, root 3 by 2, 1 by 2. So vector A is root 3 by 2 I cap plus 1 by 2 j cap. But formula to find the directional derivative is del phi dot A cap. So we have to find this A cap also. So again apply the formula of A cap, vector A upon its magnitude. Magnitude of A is, we find from this, it is cos square 30 degree plus sin square 30 degree and square root. So it is 1. You can find it from this also, but it is an easy way to compute from this cos 30 plus sin 30 degree. So A cap is again root 3 by 2 I cap plus 1 by 2 j cap. So we do the dot product of del phi with this A cap. So we get it as minus j cap dot root 3 by 2 I cap plus 1 by 2 j cap. So finally its answer is minus 1 by 2. So finally its answer is minus 1 by 2. Finally its answer is minus 1 by 2. So this was the third question. I have taken all 3 questions different. So come to next question. It is question number 4. Again we have to find the directional derivative of fxyz equal to e to the power 2x cos yz at 0, 0, 0 in the direction of the tangent to the curve. Again a different problem from previous 3 problems, and curve is given x equal to a sin t, y equal to a cos t, z equal to a t, at t equal to, it is pi by 4. It is pi by 4. So again, first of all we start by this f. We compute the gradient of this f, because f is e to the power 2x cos yz. So we find del f. So del f is, again we differentiate it with respect to x. So it is 2 equal to x cos yz I cap. Then e to x as it is, derivative of cos yz with respect to y and z in this term and this term. So derivative of cos yz is minus sin yz, and then yz is z. Derivative of yz is z. So it is z e to the power 2x sin yz j cap. Similarly, when we find, just if we find, we have to find curl f by curl z. So this e to x as it is, and derivative of cos yz is, again first of all it is minus sin yz into y, because derivative of yz with respect to z is y. So it is minus y e to the power 2x sin yz k cap. Because point is given 0, 0, 0, so we put in place of x, y, z 0. So we are having only this first term, because in the second and third term z and y are multiplied. So when we put 0, so we get all these values 0. So it is 2 I cap. So del phi is 2 I cap. Again what we have to do, we have to find the unit vector, and the directional derivative which we have to find, it is in the direction of the tangent to the curve. So we find the tangent to the curve, because the given curve is r equal to xi plus yj plus zk. So we put the value of x as a sin t, y as a cos t, and z as at. So we know that equation of tangent is given by, it is dr by dt. So we differentiate this a sin t, a cos t, at. So it is a cos t I cap minus a sin t j cap plus a k cap. So we have given t equal to pi by 4. So we put in place of t as pi by 4. So it is a cos pi by 4 I cap minus a sin 4 pi by 4 j cap plus k cap. So cos pi by 4, sin pi by 4, both are 1 by root 2. So it is a common it is a k cap, sorry, it is a k cap, that's why we can take common from all these three terms. So it is a 1 by root 2 I cap minus 1 by root 2 j cap plus k cap. So magnitude of this dr by dt is what? It is a square by 2 plus a square, so it is a root 2. So I have taken a unit vector n cap along the tangent at t equal to pi by 4. So the formula is n cap equal to dr by dt and magnitude of this dr by dt. So when we compute this, we get n cap equal to I cap by 2 minus j by 2 plus k by root 2. So in this question, because we have to find the directional derivative of the tangent to the curve, that's why we have find tangent to the curve, its magnitude and the unit vector. And finally the required directional derivative is nothing, it is del f dot n cap. Del f dot n cap. So we again do the dot product of these two vectors, del f and n cap. So it is 2 I cap minus, because del f was del phi was 2 I cap, so it is del f, because we are given f, so I will write it as f. So del f dot n cap is 2 I cap dot I by 2 minus j by 2 plus k by 2. So again I dot j I dot k are 0, so it is 2 into 1 by 2, that is 1. So this is the final answer. So hope so you enjoyed all these 4 problems related to directional derivatives. So keep watching our videos, and if you want any special video for any topic, so you can write in our comment box, and don't forget to subscribe our YouTube channel and press the bell icon for the notification for our new videos. So again, thanks a lot to all the viewers. Have a good night.